Okay, so on note 7.6, we're going to be looking at more real-world situations and having to come up with quadratics, okay? All right, so it says a homeowner has enough money to purchase 200 feet of fencing for his backyard. He wants to use this 200 feet to enclose the greatest possible area, okay? So it says draw a picture of the enclosure and label the dimensions. Your dimensions, that means length and width. You're letting your shorter side, which will be your width, equal x. So our width will be x. Okay, so we need to figure out what our length will be in terms of x, because we know our width is x. So we're given the amount of fencing. If you were talking about going around the distance around an object, you're talking about perimeter. So the perimeter formula for a rectangle is 2 times your length plus 2 times your width, because finding the perimeter of any object is adding all the sides. There's 2 lengths and there's 2 widths, okay? So what we're going to do is we're going to plug into that. We know the perimeter, which is the amount of fencing around the object or the backyard, is 200. And then I'm trying to find the length. I don't know that, but I'm going to replace the W, which is your width, with x, because we were given that we wanted the width to equal x. And I'm going to solve for L, because I want to figure out what the length is. So I'm going to subtract 2x on both sides of our equation. So we have 200 minus 2x equals 2L. Then I'm going to divide everything by 2. So your length would equal, divide each one, so I'm going to break that up into 2. So that would be 100 minus x. So that would be our length. So go ahead and label that on your paper. So 100 minus x is your length. Okay, so now on 2, we're going to express the area of the enclosure as a function of the width, which means in terms of x. So the area of a rectangle is length times width. Okay, so notice we have function notation here for a of x, which is going to represent your area. We need to know what that equals. So in terms of x, so we know the length. If you look back at your picture there, your length is 100 minus x, and we're going to have to times that by our width, which is x. So length times width there. Okay, so step 3, we're going to enter this function into the graphing calculator, and we're going to sketch a picture of the function in an appropriate viewing window. Okay, we know this is going to be a parabola because if you were to distribute this, that would end up with an x squared. Okay, so let's go to y equals. So we have 100, in parentheses, so 100 minus x times x. So that needs to be in your y equals. I'm going to go ahead and go to Zoom 6. So if you're doing this with me, Zoom 6 is just your standard viewing window. Okay? Now, we're not going to be dealing with any negatives on x or y, just like 7.5. So I'm going to go ahead and go to my window and change my x and y min to 0. Okay, so our x, we need to know what x represents in this situation. Your x in this situation, if you look back at your function, x represented the width. So I'm going to go ahead and label that on my graph. So x was the width. So I've already plugged in a 0 for my x min and then a 0 for my y min. My y on your function, that's y, that's the same thing as y, so your y is the area. Okay, our unit would be in the width feet, and the area would be feet squared. Okay, so we need to figure out what a good window would be for this situation. Okay, on your, let me go back to that window. On these type of examples, your X, which is the width, a good reasonable X max would be like half of your perimeter. Okay, so if you look back, your perimeter was 200, so if we do half of that, that would be 100. So let's plug that in on your X max and see if that works. I'm not going to increase by 1. Remember, that represents how much you're increasing by, so let's just increase by 25. Notice I am able to see that. You can barely see it, but you are able to see that x-intercept there. Okay, so I'm going to write this as 100. I'm just going to make a little note here. I did half of the perimeter, and then I increased by 25. Okay, so let's go back to window. Our Y max, remember our Y, we're talking about the area. Okay, so length times width. So let's just come up with anything. So let's try, let's say 3,000. And remember, there's not a right and wrong answer for your window as long as you're able to see the parabola. If I do 3,000, let's increase by 1,000. Notice I am able to see the entire parabola. Okay, so whatever you do in your window is how you need to graph it on your paper. So going back to window, our Y max, we did 3,000, and we increased by 1,000. Okay, so we're going to sketch that graph. Before we do that, let's label our X and Y axis. So the X axis, we're going from 0 to 100, we're increasing by 25. So 25, 50, 75, 100. On the Y, we're going from 0 to 1,000, increasing by 1,000. 1, 2, 3. If we look back at our graph on the calculator, we're just going to do a sketch. Notice it crosses at 0. I didn't do that very well. Didn't have to be exact. Okay. All right, so there's my parabola here. Now let's answer some questions. Find the maximum area of the enclosure. Okay, so if you look, anytime, we talked about yesterday, anytime you're talking about maximum or minimum and you have a parabola, you're talking about the vertex. So we will be finding the vertex on this one, but notice it says area. If you look back at your graph, Y represents the area, so you're finding the Y value of your vertex. So go back to your calculator. Second calc. Maximum is 4, so we're going to go on the left side, right side of the vertex, and then press enter again. It should say maximum. So notice your maximum area, which was the Y value, is 2,500, and the units would be feet squared, or square feet. Okay? Alright, it says, what are the dimensions that will give you that maximum area? Okay, so your dimensions means you want to find the length and the width. Okay, so we know, looking at this maximum point on the calculator, that our X, which represented the width, is 50, which was X. Okay, so since we know that, we know if you look back up at the top, the length is going to be 100 minus X. So 100 minus that 50, which would also be 50. When you're listing out your dimensions, you need to write it in this form. So 50 feet by 50 feet. Now, when you're writing it, it's not always going to be the same. So you always want to write the or I like for you to write the largest one first, which would represent your length, so length by width, okay? That's what it meant by finding your dimensions. So you have to find the x value of the vertex first, which is your width, and then 100 minus whatever you found that width to be should give you your length, which was 50. Okay, so let's look at the back. So the homeowner could enclose even more area if he used the back of his house as one side of the enclosure. So now we're only going to have 3 sides, not 4, because he's using his house as that 4th side. Okay? So we're going to draw the picture of the enclosure, label your dimensions, which means length and width. If you let shorter side, which is your width, equal x. So our width is going to equal x, but we don't know what the length will be. And then notice this time we're only going to have 3 sides. We're not going to include this side here for the fencing. Okay? So our perimeter is still the same as the front. The perimeter was 200 because that's how much fencing he has. So what we will do in order to find length, we'll do the same thing that we did on the front. We'll plug it into our perimeter formula. So we know the perimeter is 200. Now, notice I wrote down 2 lengths, but we only have 1 on this example, okay? So 200 equals the length plus 2 times the width, which is going to represent x. So we're going to subtract 2x. So 200 minus 2x equals your length, and then that's it. Okay? Since we only had 1 length, it's 200 minus 2x. Because we're not using that 4th side. Okay, so 7. Write an equation for this new area as a function of the width. So area, length times width. So our length is 200 minus 2x, and the width represents x. Remember, this is area. Okay, we're going to draw a sketch of this new function. So we need to go to our y equals. We're going to change that. It needs to be in parentheses 200 minus 2x and then times x. I'm going to go ahead and just keep it in that window that I had. And then notice that we are able to see the x-intercept there, the root, but we're not able to see the vertex at the top. So we will have to adjust. If we're wanting to go up higher, we're wanting to adjust that y max. So let's just say 5,000. Okay, notice I'm able to see it. Okay. All right, so let's write our window down. So our x-min and y-min is always going to be 0. X-min 0, x-max is 100, and we increase by 25. Our y-max is 5,000, and we're going to increase 5,000. Okay, so let's graph it. Go ahead and label. X is still going to represent your width in feet, and your y is going to represent your area in feet squared, okay, or square feet. All right, so let's go ahead and label your x and y axis. So our x is going from 0 to 100, increasing by 25. So 25, 50, 75, 100. Our y is going from 0 to 5,000, increasing by 1,000. So 1,000, 2,000, 3,000, 4,000, 5,000. Okay? And we're going to sketch it by looking at our graph on the calculator. Doesn't have to be exact. let's answer some questions. What is this maximum amount of area of the enclosure? So we're finding the vertex because it says maximum. We're talking about the area, so we're talking about the y value. So second calc, maximum is 4. Go to the left side and then the right side of your vertex. And press enter one more time. So that maximum area is your y value, which is 5,000. And that would be squared feet. On 10, what dimensions would give you that area? We know the x value, it represents the width. And notice on our calculator, your width or x value is 50. And then if you go back up to the top to find length, it's 200 minus 2x. And x was 50. So that would be 200 minus 100, which gives you 100 for your length. So remember on the front, when you're finding dimensions, I talked about I want your larger one to be first. So 100 feet by 50 feet. So that way your length is first when you're writing your dimensions. Okay, so this is another way that you could use parabolas in the real world, talking about perimeter and talking about area.